Hey guys, today we're going to talk about pressure and gas behavior. So we're going to define what that means. So if we start, pressure just means the force on the walls of a container from the particles bouncing against it. So if we put that into a picture form, it looks like this. Think about each of these boxes as a room or a container, and we know that gases, when you draw them, are very spread out particles. And as they move around, they might bounce and hit the walls of the container, and they kind of do that randomly, and that's what pressure is doing. As those particles bounce around, they're putting pressure on the walls every time they hit it. But now one of the things that can happen is you can get really high pressure. And so high pressure would mean if I have a lot of gas particles in here, they're going to bounce around on the wall a lot more, which means that that pressure is going to be higher. Because of those extra gas particles in there, we have higher pressure. Those particles will bounce on the wall more and exert more force on the walls. What can end up happening in that case is when the pressure gets too high, that force can actually cause the container to burst. And the room or the container, the box, whatever you have, the particles can actually burst it open from the bouncing against it that they're doing. And so the reason that we care about pressure is we measure it with a barometer. So a barometer is a tool used to measure the atmospheric pressure. So this means the atmosphere, which is the air around your head right now. There's an atmosphere on top of your head pushing down on your brain, but it's not too much. It's enough that you can handle it. And so here's what a barometer looks like. It's this tool right here. And so the air that's out here, just like it's pushing down on your head, pushes down on the barometer, and the more that it does that, that makes the liquid go up. So high pressure would go up here at the top of the tube. If it was a lower pressure day, it wouldn't be as high. This is actually used by meteorologists to predict weather. So when you've got high atmospheric pressure, it's a really nice day. We just had a lot of rain. That means we have some low pressure. We've got some bad weather rolling in. Another place that you hear about pressure is when you go to the doctor and you get your blood pressure taken. So pressure is being exerted by the blood on the walls of your arteries and veins. And so we measure that and we say normal blood pressure is 120/80 mmHg. And so we're going to talk about what that means. The tricky thing about pressure is there's not just one unit. There are several different units that we can use and put on a pressure number. So we might say atmospheres, and so this is what we're talking about, the air above your head. Millimeters of mercury, so the symbol for that is mmHg, or it could be kilopascals. And so you're going to see all three interchangeably, so you can't just pick one, you're going to have to know all three. To give you a little frame of reference, if I have 1 atmosphere, that equals 760 millimeters of mercury, which equals 101.3 kPa. These are numbers you need to know. Okay, so put a star, circle, arrow, whatever next to those numbers and those units you need to get in your brain. Okay, these all apply to gases, and so we're going to talk about, well, what does it mean to be a gas? When we talk about ideal gases, the word ideal literally means perfect. So this means it has a perfect behavior, and what that does is it makes our math and our calculations that we're eventually going to do easier. So if you are an ideal gas, if you're a perfect gas, you are going to be risen. So it's RISEN. And so this is going to help you remember what a gas does when it is ideal. So let's talk about what each of those things stands for. So R stands for random. The molecules move really randomly. They go wherever they want. They don't care about each other. It's not a set pattern. They just do their thing. The I stands for independent. The molecules don't attract or repel each other. They don't go with their friends. They go wherever they want to go, and that's it. S means that they go straight. The molecules only move in straight lines. So when a molecule goes, it could go like that, but it couldn't start moving and then curve and then bounce that way. So this would never happen. They'll only go in straight lines. E stands for elastic collisions. Elastic, it's kind of like a rubber band. You can stretch it out and do whatever you want and it'll always go back. It doesn't lose any energy when the particles collide. When they collide with each other, when they collide with the wall, they just hit each other and they bounce off and they keep going. Lastly is N for no space. The molecules don't have any volume. Remember, volume means the same as space, but they don't have any. They're so small that if I think about them inside of that box, they really don't take up much room because there are so few of them and because they are so little. Alright, so that's all you have to know about gas behavior and ideal gases. Let me know if you have any questions.